Our home solar system operates with a reassuring pattern. Planets travel in steady, circular tracks around a single central star, with rocky worlds in the inner orbits and gas giants drifting quietly in the freezing outer zones. But as humanity aims its lenses past our immediate neighborhood, that orderly model begins to fracture. We are finding worlds that defy the textbook laws of physics, planets that contradict our basic understanding of how the universe functions. Tools like the Hubble Space Telescope have spent decades peering billions of light-years into the dark, capturing the faint signatures of these deep space anomalies. These observations pull us away from the calm mechanics of our local planets and into a violent reality hidden within the greater galaxy. Every impossible world we find reveals a universe that is far more volatile than our own stable corner suggests. Standard planetary formation dictates that gas giants must whirl in the freezing outer reaches of a star system. Out there, a young planet has the space and the dust supply needed to slowly pull in material and reach massive proportions. HD 188753AB exists where it shouldn't. It is a gas giant slightly heavier than Jupiter, but it sits in a tight triple-star system. The gravity of its two smaller companion stars should have cleared out the very dust and gas this planet needed to form, leaving it with no room to grow. If you stood on the hypothetical moon here, you would watch the main sun set, only for two more suns to immediately take its place. Your shadow would split in 3 directions, and true night would never arrive. WASP-17b presents a different structural problem. It is almost twice as wide as Jupiter, but contains only half the mass. This creates an extremely low density, making the entire planet light enough to float on water like a giant beach ball. While most planets travel in the direction their star spins, WASP-17b moves backward. It traces a completely opposite retrograde path. This loop suggests extreme violence. A near collision likely flung the planet off its original path into this inverted orbit. These systems demonstrate that our traditional models fail to account for the chaotic environments of many young star systems. In our solar system, thermodynamics are straightforward. Heat melts ice, and atmospheres reflect or absorb light based on predictable chemical compositions. Gliese 436b shatters that logic. Temperatures here reach 820 degrees Fahrenheit, hot enough to melt lead. But the planet's gravity is so crushing that it squeezes water into a solid state. It is a world made of burning hot ice. Because the planet sits so close to its star, it is being blasted by intense radiation that strips away its atmosphere, creating an 8 million-mile tail of hydrogen gas that makes the world look like a colossal comet. TRES 2b sits at the other extreme. It is darker than coal or black acrylic paint, reflecting less than 1% of the light that hits it. Because the heat is too intense for reflective clouds to form, the planet glows with a dim red heat, like an ember in the void. WASP-127b features weather that defies standard physics. Supersonic jet streams scream around its equator at 20,500 miles per hour, fast enough to cross the Earth in under an hour. These winds move 6 times faster than the planet itself rotates. The extreme parameters of these worlds create thermodynamic states that are entirely alien to our local understanding of nature. When a star exhausts its fuel and expands into a red giant, the resulting growth usually obliterates every planet in the system. KOI-55 survived being eaten alive. 18 million years ago, it plunged deep inside the layers of its host star. The star evaporated the planet's gas, but its rocky core remained, and it still orbits today at a scorched temperature of 12,000 degrees Fahrenheit. In the Lich system, we find zombie planets orbiting a pulsar, the dead, rapidly spinning core of a collapsed star. These worlds likely formed from the debris left over after 2 white dwarf stars collided and merged billions of years ago. Standing on one of these planets would be a maddening experience. The pulsar shoots out beams of energy 160 times every second, acting like a violent strobe light that constantly pulses across the landscape. Some planets aren't even there at all. In 2008, astronomers celebrated the direct photograph of Fomalhaut b. But as the years passed, the planet began to fade and drift away from its star until it completely vanished. The mystery was solved in 2020. The planet never existed. It was actually an expanding dust cloud created when two giant icy asteroids smashed into each other just before the first photos were taken. These stellar graveyards show that the end of a star's life is not a quiet event, but a period of surviving remnants and violent illusions. Compared to these rule-breaking anomalies, the giants in our own system appear remarkably stable. Jupiter follows a steady, predictable path, holding its storms behind familiar bands of color for billions of years. Every discovery of an impossible world sends astrophysicists back to the drawing board. These planets prove that our current understanding of the universe is still incomplete. These extreme worlds act as cosmic laboratories, allowing us to observe the limits of physics under conditions of heat and pressure that we could never replicate on Earth. We are building even larger tools, like the James Webb Space Telescope, to peer deeper into these alien atmospheres and unlock the secrets of their survival. The data reveals a galaxy defined by extreme conditions, where most worlds are shaped by crushing gravity and searing radiation. The stability we enjoy on Earth is a rare exception. Our quiet, predictable existence stands out as a unique outlier in a fundamentally hostile and chaotic universe.